In June 1944, near St. Lo, a Sherman tank was struck 20 times and did not burn. Each impact came from German 75mm guns hidden beyond the hedgerow. Smoke rose, but the crew inside remained alive. Its armor, dismissed as paper, was no steel at all. It was laminated cellulose pressed with resin in a field workshop only days earlier. Field records listed the plates as 2 inches thick, half the weight of standard steel, bolted in haste under dim lamps. Soldiers who saw them laughed. They said the first hit would shred the tank. Some called it a coffin wrapped in scrap. Yet on that June morning, the fake armor turned blast into endurance. Resin fused, layers swelled, and shock dispersed sideways through the grain. When the firing ended, the turret still turned. The gun still loaded. The crew stepped out coated in dust, their vehicle blackened yet intact. 20 scars crossed its flank like fingerprints of disbelief. Observers logged each crater, each failed penetration, as if recording an error in physics. It had been called a toy, a trick, a sheet of paper. It stopped 20 shells in Normandy. By spring 1944, the Sherman tank stood as both strength and liability of the Allied advance. It was fast, easy to maintain, built by the tens of thousands, yet fatally thin against German 75 and 88mm guns. Crews knew it as the Ronson, the lighter that always lit on the first try. In the hedgerows of Normandy, that grim joke felt literal. Before the invasion, engineers had searched for any method to keep tanks alive. They welded spare track links across hulls, stacked sandbags on decks, hung plow blades as armor skirts. Each fix added weight and slowed movement. Against high-velocity fire, nothing mattered. A single round at 1,800 yards could pierce 3 inches of steel. Numbers did not leave room for courage. At scattered depots, field workshops began improvising. Mechanics scavenged wrecks, cut plate from doors, packed cement into boxes, bolted timber over weak points. The next proposal seemed absurd. Replace steel with laminated cellulose soaked in resin. It came from a materials engineer who had studied experimental composites at Aberdeen Proving Ground the year before. Records there had shown fiberboard bonded by phenolic resin could stop shell fragments moving at 2,000 feet per second. The discovery had been filed away, too unorthodox for production. Normandy changed the rules. Steel mills were an ocean away. Resin could be found in aircraft repair kits. The engineer suggested pressing multiple fiber sheets under steam, coating them with resin until the structure hardened like glass. Each panel weighed half of steel and could be drilled, cut, and fitted by hand. Resistance to heat and shock was far higher than anyone expected. The reaction was laughter. Crews called it madness, armor made from shipping crates. They imagined the panels igniting on the first impact. Still, the data spoke quietly. Field notes estimated the composite could absorb 24,000 pounds per square inch before cracking. The math did not care about opinions. In early June, one tank crew from the 743rd Battalion agreed to try it. Working overnight, they mounted the pale amber plates across the right flank of their Sherman. Bolts tightened to 55 foot-pounds, gaps sealed with resin paste. By dawn, the job was done. The tank looked patched with wood. Neighbors in the bivouac jeered. "You plan to stop 88s with cardboard?" someone shouted. The crew ignored them. Their orders were to test, record, and survive if they could. That afternoon, the battalion rolled toward St. Lo. Rain misted over the hedges. The composite armor darkened and cooled, absorbing sunlight instead of reflecting it. From a distance, the patched tank looked like any other. Until fire came. They believed it would melt on the first hit. It did not. The idea had begun a year earlier, deep inside Aberdeen's ordnance files. In 1943, engineers studying aircraft materials recorded a strange result. Laminated cellulose, when cured with phenolic resin, absorbed impact energy without shattering. At 68 pounds per cubic foot, it held tensile strength near 32,000 pounds per square inch, light as wood, strong as steel. It was archived as laboratory trivia, never meant for war. War, however, was a furnace for discarded ideas. By May 1944, tank losses in training convoys forced engineers to improvise with what lay within reach. Steel needed furnaces. Resin needed only heat and patience. Field depots near Isigny became accidental laboratories. From the wreckage of bridges and crates, mechanics cut cellulose boards into squares and stacked them in presses built from armor plate and steam pipes. The gauges read 240 degrees Fahrenheit, enough to melt the resin evenly through the fiber. Each cycle took 40 minutes, every sheet fused tighter than the last. When cooled, the first panel rang like hardwood under a hammer, 3 feet by 2.5, 2 inches thick, surface ambered and smooth. They called it Paper Plate A1. To prove it, they fired a captured 37mm shell at 50 yards. The round struck, smoked, and stopped. A second hit nearby bulged the back 1/10 inch. Heat at the crater rim reached 480 degrees Fahrenheit, resin charred but no crack formed. Among the watching men stood Sergeant Raymond Miller, 26, once a furniture builder from Ohio. He understood grain, stress, and bonding. Steel broke at its limit, wood bent and recovered. That difference stayed with him. He proposed mounting the laminate on his own Sherman, an M4A1 nicknamed Juliet. The idea met silence, then a reluctant nod from command. One test tank was expendable. Working through night rain, Miller's crew drilled holes 6 inches apart, bolted the plates to the hull, and sealed seams with resin paste. The added weight barely reached 180 kilograms, half of welded track armor. In the lantern light, the panels looked wrong, dull brown, grain showing beneath thin paint, the surface already tacky from heat. At dawn, they rolled toward the front. The resin smell mixed with oil and wet earth. Inside, the crew felt the change instantly. The tank rode quieter. Steel echoes had vanished. Dust shimmer decreased. The surface absorbed heat instead of reflecting it. None of that appeared in reports, but the difference marked the start of a new rhythm, silence in motion. For 2 days, Juliet advanced without contact. Mechanics inspected the armor each evening. Moisture stayed below 5%, no swelling or peel. Rain pooled, then slid off. The data looked ordinary, which was extraordinary. Other crews began to ask for samples. The depot pressed more plates through the night, timing each cure cycle by wristwatch. On June 10th, the experiment met its proof. At 0820 hours, German 75mm guns opened from a hedge gap 800 yards ahead. The lead steel-sided Sherman stopped under 2 hits. Juliet turned to flank, exposing her laminate side. The third shell struck 20 degrees off angle. Smoke burst, but the tank kept moving. Thermal crayons on the inner hull flashed orange, then cooled within 20 seconds. Pressure sensors read 24,000 pounds per square inch, within Aberdeen's theoretical limit. More shells came, one hit lower, another at mid-height. Each left only a bruise. After 5 impacts, observers approached under smoke and photographed the damage. 5 craters, none through. The laminate had behaved exactly as paper models once predicted. It had failed everywhere a little, nowhere completely. By midday, Juliet bore 20 scars. The inner hull paint had bubbled, but no fire burned. Resin fibers had separated and fused again under heat, redistributing stress sideways. Metallurgists later called it distributed failure. In the field, it was called survival. Miller's report that night was brief and technical. He listed distances, calibers, and timings ending with one line: armor held, turret operational. Signed in grease and dust, it went into the battalion log. Within 48 hours, 6 more Shermans carried the same protection. The workshop ran its presses 24 hours a day, 2 plates per cycle, 4 tanks every night. Resin drums emptied fast. Each fresh panel emerged amber and glossy, then cooled to brown under rain. Steam hissed through pipes built from salvaged exhaust manifolds. Every shift ended with 2 sentences chalked on the wall. Cycle 40 minutes, do not shorten. Wright Field, December 1943. The original test log had claimed endurance for 18 impacts per plate, plus or minus 10%. In Normandy, Miller's armor surpassed that by 2. He read the figures once more before sending them. Numbers were not decoration, they were reason. Every ton mattered, every bolt carried proof, every hour was measured, every part counted. At dawn on June 10th, gray fog rolled across the meadows west of Isigny. 6 Shermans now carried the amber plates cured overnight beneath canvas and steam. Mechanics had torqued every bolt to 55 foot-pounds, resin seams cooled for 8 hours, and chalk grids covered each flank for damage reports. To most soldiers, the tanks looked patched with barnwood. To the men inside, they felt like experiments with no control group. The first engagement began at 0820. A German 75mm gun fired from a hedge gap 600 yards ahead. The lead tank, still bare steel, stopped after 2 hits. Juliet moved right to draw the next. The round struck her composite flank at a shallow 20-degree angle and vanished in dust. Smoke rose, but no flash followed. The crew kept moving. Observers calculated impact energy below Aberdeen's predicted limit for full penetration. Thermal crayons on the inner hull shifted to orange, then faded in 20 seconds. The driver's voice stayed calm. Still turning. One field note added, "Shock dispersed laterally, not through." By 1000 hours, all 6 composite tanks had been hit at least once. None showed interior spall. Recovery teams cut a square from Juliet's plate for inspection. Beneath the burn marks, resin fibers had fractured but interlocked. The phenomenon confirmed Miller's term, distributed failure. It failed gradually, never explosively. In the depot, 2 miles behind, engineers pushed their presses harder. Each cycle lasted 40 minutes, yielding 3 plates per hour. 4 plates covered 1 hull side. A complete set required 6 hours of cure and 2 of cooling. Production reached 2 tanks per night, powered by the same generator that ran the radio trucks. Every hour became inventory. At 1400, the unit entered the sunken lanes below Hill 183. Enemy guns waited in orchards. Juliet absorbed 2 direct hits low on her right hull. The second round delaminated the outer layer across 3 inches, but stopped cold at the next. The tank's sponson rang like struck wood, not metal. Miller chalked each crater, called bearings, and advanced. Mud and smoke soon covered the amber sheen, turning it gray. From a distance, the composite looked like rough planking. Infantry behind mistook it for field camouflage. The irony suited Miller. What the enemy saw as weakness had become concealment. By dusk, field records listed 24 hits on laminate surfaces across the 6 tanks. 0 penetrations. Steel hulls in the same sector showed 3. The log included an observation in pencil. Angled shock transfers into bolts, not crew. Geometry shielded where chemistry began. Morning of June 11th opened cold and bright. Crews brushed dust from the plates and traced the chalk lines again. New instructions from the depot arrived, with resin drums. Add a thin asphalt wash to seal impact cracks. Each tank carried 2 spare panels lashed to the rear deck, swapped in 15 minutes with 4 men, and 1 jack handle. Torque A, 55 foot-pounds, was written in grease on the hull. At 0955, an 88mm gun fired from a ridge above St. Clair. The first round struck the bow of a steel-sided Sherman, cutting through. The second found Juliet's corner patch, recently replaced. It shattered, but stayed pinned under its bolts. Dust filled the lane, then cleared to show the tank still running. The next shot fell short. The crew advanced under their own smoke and silenced the gun with high-explosive rounds at 200 yards. The day settled into an odd calm. Crews realized the fear of instant fire had gone. Hits still shook the hull, but no flame followed. The armor did not promise safety. It bought seconds, the difference between escape and loss. Each hour added proof, and proof built confidence faster than morale speeches. In the workshop, engineers refined the cure schedule. A brief preheat of 180 degrees Fahrenheit cut cycle time, but tests showed bond lines weakened. They reverted to full heat, 240 degrees steady, moisture below 5%. Steam hissed through scavenged pipes, water dripping into trenches that never cooled. They logged temperature, pressure, and yield as if running a factory on the front line. June 12th brought the heaviest bombardment yet. Fog lifted to reveal German guns along the ridge near St. Clair. Within minutes, shells hammered Juliet broadside, 5 impacts in 60 seconds. Dust cascaded from seams, gauges quivered, and the tank kept rolling. When firing ceased, observers measured crater depth at half an inch, back face bulge less than 1/8. The interior temperature never rose above 140 degrees Fahrenheit. In the turret, the commander spoke through vibration. "Range 600, deflection left 2, fire!" The gun barked, cycling at 8 rounds per minute. The loader's gloves stuck to resin dust. They advanced hedgerow to hedgerow, silent between bursts. Each mile carried more numbers than words. That evening, after-action reports read like a technical ledger. 46 laminate hits for the day, 1 partial delamination, 0 penetrations. Steel-sided survivors, 9 hits, 2 through, 1 burned. Damage depth averaged 3/8 inch, consistent with prior data. The math lined up. The depot rationed resin by contact rate, priority to tanks on point. Engineers diluted the surface coat 20% to stretch supply, finding no loss of seal quality. Core saturation remained full. Efficiency increased. Process became doctrine. That night, rain returned, softening the lanes and washing the tanks clean. The composite plates darkened, swelled by fractions of a millimeter, then stabilized as resin sealed itself again. Mechanics tapped each surface with wrench handles, solid tones all around. They painted fresh grids, reset counters, and logged hours for the next shift. At dawn, the presses hissed behind tarpaulins. Men slept in turns beside the heat, faces streaked with resin dust. Each cycle ended with a single chalk line on the boiler wall. Output sustained. By then, the word cardboard had vanished from conversation. Crews simply called them laminate tanks. No longer a joke, just a weapon built from the same rule that governed every success of the war: scale, precision, repetition. The pattern held, and it would keep holding. June 14th opened with low clouds and a soaked map. The battalion moved east, cutting a supply lane towards St. Clair. 3 new tanks now carried composite on both flanks, 9 in total. Overnight, engineers had added a narrow forward strip to deflect glancing hits and tighten bolt spacing to 6 inches. Each adjustment was logged by hand, then tested in battle hours later. At 0920, the first strike came. A 75 millimeter gun hidden inside a barn fired twice at 650 yards. The first shell scraped the forward strip at 30 degrees and disintegrated. The second hit higher, cracked the surface, and stopped cold. Interior sensors measured back-face deflection below 1/8 inch. The driver kept speed. The gunner replied with 2 rounds of high explosive. The barn collapsed. In the depot, presses ran through steam and fatigue. Edge chamfers were trimmed to 10 millimeters to reduce corner breaks. Steam lines purged 60 seconds per cycle to keep heat even. Each cured plate weighed 190 kilograms, lighter than track armor, stronger than steel scrap. By midday, the ridge erupted again. A full battery of 88s sighted the column from beyond the saddle. The second tank in line, steel-sighted, caught the first round and burned. Juliet turned broadside to take the next volley. 3 shells hit within 30 seconds. One ripped away a corner of her composite, resin fibers dangling. Inside, the air filled with dust, but no flame. The commander ordered the advance. A runner brought spares on a 2-wheel cart. Under smoke, 4 men unbolted the shattered slab and slid a fresh one on. 12 minutes from impact to restart. Each nut checked by wrench and hand. The tank rolled again before the smoke cleared. Field time record, swap 12. Evening light revealed the day's score: 62 hits on laminate, 0 penetrations. Mechanics examined a removed plate and found a thin, glassy ridge where resin had flowed and hardened under heat. It had not melted. It had evolved. The pattern held. June 15th shifted from open lanes to orchards. Fire came from behind stone walls and tree rows. The composite stopped direct rounds, but fragments still swept across turret rings. Crews improvised a shallow skirt of 2-ply strips and canvas. It could not stop an armor-piercing shell, but it blunted fragments that once cut through steel. At 10:30, a German Stug fired twice from behind a shed. The first shot shredded the canvas skirt. The second slammed square into the laminate. The plate cratered but stayed whole. Inside the turret, the loader kept his rhythm at 8 rounds per minute. 3 shots later, the shed folded inward. Silence replaced theory. That night, engineers reinforced every bolt head with a stake mark to prevent loosening under vibration. Plates were scuffed lightly and resealed with thin resin wash. Moisture check stayed below 2%. Cure time extended 5 minutes in cooler air. Output slowed, quality improved. June 16th turned experiment into method. One tank carried a test sandwich of steel, laminate, and a thin outer doubler. At 400 yards, a 75mm shell cratered the front layer and stopped between steel skins. Crater depth, 1/4 inch. Weight penalty, 30 kilograms. Log note, composite plus steel optimum. Crews reorganized the inside. Ammunition moved away from the most battered zones. Sandbags removed where they trap moisture. A spare laminate square now shielded each radio. The changes were small but cumulative, every hit measured, every repair logged. By afternoon, resin stock neared exhaustion. Quartermasters scavenged aircraft crates for leftover phenolic drums. Ratios drifted, color varied, strength held. The new mix set darker but proved equal. The depot rule went onto the wall. Seal light, core heavy. Rain swept in at 1500, hammering hedgerows and decks. Water streaked down the composite and slid off in clean sheets. Steel boiled with heat blisters. Resin stayed cool. Crews leaned against their hulls and watched the contrast. The difference meant hours of comfort and years of design. June 17th brought controlled tests with captured guns. A POC 40 fired 3 rounds at salvaged plates stacked against a bank. At 400 yards, penetration failed. At 300, it stalled halfway. The data matched field results. The note beneath read, "Angle 30 degrees ideal, energy spread confirmed." The next morning, the ridge opened towards St. Lo. Gardens burned, barns collapsed, and every field hit a gun. Juliet led again, her flank layered with scars. 2 new craters formed beside old ones, resin fibers frayed like paper. The commander's voice stayed level. "Range 500, fire!" The tank rolled through dust and silence, the chalk grid now a record of survival. Analysts at the rear turned wounds into tables. Average crater depth 3/8 inch, back face bulge 1/10, optimal obliquity 30 degrees. Replacement time 12 minutes. 4 plates consumed 1 drum of resin. These figures would outlive the men who wrote them. A rumor crossed the lines. The Germans called them wood tanks or chemical armor. The names changed nothing. Composite tanks led, steel tanks followed. Survival decided order. By June 18th, totals spoke clearly. 91 hits on laminate, 0 burn-throughs, 2 tracks lost, 1 turret jam cleared in minutes. Steel hulls in the same fight, 14 hits, 3 penetrations, 2 evacuations. The numbers formed a single truth that needed no speech. The material worked. Night brought steam, silence, and discipline. Presses hissed beneath tarps, curing the next day's armor. Plates cooled on wooden slats until amber turned dull brown. Each was stenciled with unit, date, and thickness, 2.2 inches. The chief's logbook ended that day with a single line, written in resin-stained ink. Composite fulfilled purpose. Supply will fail before structure does. It was not theory now. It was arithmetic. 20 shells, 1 tank, still alive. By June 19th, disbelief had turned into measurement. Reports from the 743rd Battalion reached the engineer board at Cherbourg, each repeating the same phrase. Composite-sided tanks returned. Couriers carried fragments in sandbags, blackened resin plates, scorched, yet still intact. Metallurgists tapped them with hammers and wrote a single note. Integrity retained after multiple impacts. Enemy artillery crews had already noticed. Prisoners later confirmed the new American tanks were called Holzpanzer, wood armor. Orders were issued to aim for turrets and rear decks, avoiding the mysterious flanks. The logic was sound, the fear real. Rounds that should have pierced cleanly now cratered and bounced. Gunners spent ammunition on the same scar only to find the first shot had already done all the damage physics would allow. At St. Clair, exhaustion replaced surprise. The battalion had moved for 30 consecutive hours through lanes of smoke and mud. Presses in the rear never cooled. Steam drifted through ruined barns carrying the sharp smell of phenol. Resin drums dropped to a third of supply. The last batches were cured too hot, their color turning darker, almost black. At 0640, Juliet climbed a ridge under morning haze. The first German shell, an 88mm armor-piercing, hit low on the right side. The plate had already taken 5 blows from the week before. The impact cracked it halfway through. Resin bubbled out and hardened instantly. A second shell followed. It punched into the same scar but failed to pass. Heat signatures peaked at 480 degrees Fahrenheit, well below ignition. The crew advanced another 50 yards, engine roaring over debris. Behind them, a steel-sided Sherman caught 2 rounds and flamed within seconds. The contrast was unmistakable. Composite meant survival, not immunity, but that difference reshaped confidence. By noon, the ridge was quiet. Juliet stood at the crest with 2 panels split and 4 blistered. Mechanics logged each wound, then unbolted the worst plate for study. Under lantern light, the inner layers showed neat stratification. 31 sheets of cellulose fused as one. Only the outer 3 had ruptured. The bolts had held. The conclusion in the log was short. Composite fails progressively. Steel fails all at once. The next pages turned arithmetic into doctrine. Fuel efficiency improved 2% per mile from reduced weight. Repair time per hit averaged 12 minutes. Every number reinforced what men already knew. Efficiency was survival. Yet the chemistry reached its limit. Resin was gone by June 22nd. Engineers diluted the last barrels with alcohol to thin the mix, curing longer to compensate. One defective panel delaminated on the first strike and peeled away like bark. It became the only full structural failure of the experiment. The lesson was immediate. The composite depended on perfect bonding. Still, the battalion pressed forward. By June 23rd, they entered the outskirts of St. Lo. The city was rubble, each wall a gun nest. Tanks fought block to block. Juliet led, her flanks dark as coal, every plate marked and rebolted. Machine gun fire sparked harmlessly across the resin skin. At 1300, a German 75 from a cellar fired 3 times in under a minute. 2 shells struck composite and cratered. The third slid under the skirt and tore through steel just above the track. The driver was wounded but alive. Fuel tanks held. Ammunition stayed cold. After battle, the engineers measured the hole, 3 inches wide, 3.5 deep, stopped by a stringer brace. 1 inch higher would have meant a burn. The report filed that night read like data, not emotion. Penetration partial, crew functional, engine intact. At headquarters, analysts compiled every figure since June 10th. Out of 91 recorded laminate strikes, 0 ammunition detonations occurred. None ignited fuel. 1 full plate loss. In margin notes, an officer wrote, "Energy divided survival multiplied." The depot teams continued without sleep. 1 generator failed. They repaired it with scavenged tractor parts. Bearings were lubricated with gear oil mixed with cooking grease. When water lines froze at night, they rerouted kitchen steam. Improvisation had become procedure. By June 25th, the battle reached its peak. 200 shells rained across the battalion zone. 5 tanks were hit directly. 3 wore laminate armor. 2 limped back to the depot. The third was Juliet. 9 shells struck her sides in 90 minutes. The right panel fractured completely, splitting from top to bottom. Yet no fire followed. The crew climbed out black with soot and exhaustion. When the ridge fell silent, engineers picked through wrecks. They found shards of resin fused like glass, fibers stretched and frozen in direction of impact. The cross-section revealed why the armor had survived. Force had spread laterally until it exhausted itself. Heat was the only casualty. That evening, Juliet's panels were tagged for study. The field log summarized all remaining vehicles. 9 composite tanks deployed, 6 still operational. Average survival rate 140% higher than steel baseline. In technical terms, that meant more missions completed per tank, the true currency of war. Hours later, a courier brought orders from Cherbourg. The composite project was to end. Resin shipments had stopped, and steel stocks were plentiful again. The final memo read, "Experimental field armor successful, unsustainable. Program terminated." No ceremony followed. Crews who had lived inside those patched hulls took the news quietly. Some kept damaged panels as souvenirs. One mounted a half-plate behind the driver's seat, a charm against chance. Others left notes on the fragments, dates, coordinates, tally marks. By mid-July, Juliet rested stripped in a depot yard. Her armor leaned against a wall, tagged for shipment. One plate carried chalk handwriting. Tested, 20 shells, held. The tag read APL 1944-17. In October, Aberdeen technicians placed that slab beneath a hydraulic press. Load increased to real what, 200 pounds per square inch per second. At 24,000 psi, it fractured silently. The test officer's log echoed Miller's Normandy report. Failure gradual, performance above prediction. The annotation below read, field endurance exceeded control by 1 cycle. The numbers had already decided. Steel remained the standard, but the lesson traveled further. In post-war years, laminated composites reappeared as glass fiber, aluminum honeycomb, and ceramic plate. Each bore the same equation: divide force, extend life. What began as an act of desperation beside a hedgerow had become a blueprint for the next generation of armor. The men who made it never wrote memoirs. Their work lived inside technical archives, filed between serial numbers. Yet within those quiet pages, the paradox stayed intact. Paper outlasting steel, weakness engineered into strength. In a glass case at Aberdeen, the panel still rests under soft light. No plaque mentions the battle, only its designation. Its silence carries the proof no statistic can exceed. The tank that should have burned never did, and the armor that looked like paper had already changed the future. By August 1944, the reports from Normandy had reached Washington. The front had moved beyond St. Lo, but the results traveled faster than the war. The Engineer Board filed its summary under code EB1 1467. Field fabricated laminated armor, cellulose resin type, operationally effective, logistically constrained. Behind the plain language was an unplanned revolution in material science. At Aberdeen, technicians sliced the recovered panels into thin samples. Under magnification, each layer showed what no metal ever could: tiny cracks that had dispersed energy instead of concentrating it. The fractures radiated like veins, evidence that failure had been engineered to slow itself down. X-ray tests confirmed no complete breaks. In every sample, stress had traveled sideways and died in silence. The official notes measured tensile strength at 32,000 pounds per square inch and deflection under 1/8. Those figures, once field improvisation, now entered laboratory truth. Representatives from General Motors, Chrysler, and Fisher Body attended the analysis. They saw in the paper plate a future pattern: modular armor built in layers, each tuned to absorb a different kind of shock. The principle was written down, stamped deferred, and filed away for peacetime. But ideas in war rarely stay buried. In 1948, the Aberdeen Research Division reopened the concept under Project Laminar. The aim was to merge cellulose fiber with aluminum for a lightweight armor sandwich. Trials at Fort Knox in 1951 reproduced Normandy's data within tolerance. 2-inch fiber panels stopped 60mm rounds with 40% less weight. Reports noted reduced flame spread, improved fatigue life, and a new term: composite armor. Across the ocean, the Soviet design bureaus followed similar logic. From captured Allied files, they developed textilite armor, resin-impregnated fabric layered between steel sheets. By the mid-1950s, both sides of the Iron Curtain had unknowingly adopted the same formula born from a hedgerow experiment. Each generation called it something new, but the physics stayed constant. Divide energy, delay destruction, survive. Raymond Miller returned home quietly. He worked again in a furniture plant in Ohio, where laminated wood met the same presses he had used in France. Asked later about the armor, he said only, "We were tired of burning. If it took paper to stop it, we tried paper." His words never reached the record, but his math did. The resin he had used, phenol formaldehyde, outlived the tanks. Between 1944 and 1948, its production quadrupled, feeding post-war industries from telephones to aircraft interiors. A single line in an engineer board memo traced that surge to wartime consumption. Resin utilization increased 400% following field adaptation. War had converted chemistry into economy. 2 decades later, British researchers at Cherbourg returned to the same theory. By 1970, they unveiled a new protection matrix: steel, ceramic, and fiber layers sealed in resin, Chobham armor. The numbers behind it matched Aberdeen's 1944 charts almost exactly. The material once mocked, as fake had become the invisible skin of modern tanks. History called the 20th century the Age of Steel. The files at Aberdeen told a quieter story, an age of materials that learned to bend, absorb, and endure. The paper armor of Normandy was neither miracle nor accident. It was proof that flexibility, not hardness, defined survival. In 1972, archivists rediscovered Miller's final field log. The handwriting was smeared with resin dust. It contained only one complete sentence beneath the tables: "Hit 20 times. Crew alive." The line now rests beside pressure charts and temperature curves in the museum's sealed vault. It remains the only human phrase in an archive built entirely of data. The war had rewritten the limits of materials, and every line of that rewrite began on a tank that refused to burn. In the summer calm after St. Lo, the wrecks lay half-buried under weeds. Sunlight glinted across their broken tracks, but the flanks that had taken 20 shells showed no holes. To a passerby, they were just burned machines. Only those who knew the numbers understood why they had not exploded. At Aberdeen, one surviving plate stood behind glass, dark amber, warped, still faintly smelling of resin. Its label read, "Laminated cellulose, Normandy, 1944." No photo accompanied it. The silence between its cracks was explanation enough. Years later, the same principle guarded new armor: ceramic tiles, fiber cores, layered steel. Every improvement followed the rule that Miller proved by accident. Strength could come from division, not resistance. The field that once laughed at paper armor now built its future upon it. No monument marks the experiment. No medal lists the crew that stayed alive because of chemistry and time. Yet the evidence endures in equations, in temperature charts, in the one tank that refused to ignite. By every metric, it should have died that morning near St. Lo. It did not. The armor called fake had held through fire and disbelief. It was paper only by name.